This activity is about MDD10, which is a driver used to drive a DC motor. It can control up to two DC motors at the same time with two modes, lock and tie phase (PWM) and sign magnitude (PWM). Before we go on with the details, you better check first that your battery box, DC motor, and MDD10 are working well. The first test is simply connecting the battery to the motor directly. The motor should run properly. You should observe that the direction of rotation will be opposite when the polarities of the battery are swapped. To use MDD10 with Raspberry Pi, you need to stack MDD10 on top of the Raspberry Pi by using two extenders. They are stored in the package of MDD10 and MakerP hat. Let's see what's on the MDD10. There are two switches for each motor, named M1 and M2. Letter A or B represents the direction of rotation. We will test the connection with motors by using these two switches later. Pin number 4 and pin number 6 are used to supply the voltage to the fan of the heatsink. The ground of the Raspberry Pi and MDD10 must be the same one, so make sure that pin number 14 is connected to the ground of MDD10. The two wires from each motor will be connected to M1A, M1B, M2A, and M2B respectively. And finally, the DC voltage from the battery box will be connected to MDD10 via VM and GND. So up to now, you will get a similar thing like this. In this picture, only one motor is connected. Here comes the second test. As you see, if the switch M1A is placed, the motor will rotate in one direction, and when the switch M1B is pressed, the motor will rotate in the opposite direction, similar to swapping the two wires. Up to now, it seems like there is nothing wrong. Then we are good to go to the next thing. As there are two modes to control the motor, let's compare the Python code for these two modes. To set up, we use the same GPIO setup, but the main difference is about the pulse width modulation, PWM. In lock and tie phase, the digital pin number 24 and 26 are used, but for sign magnitude, analog pin number 12 and 13 are used. From this big table shown, for the lock and tie phase first, the command P1 start 0 is used to set the direction to be forward, and we use P1 start 100 for backward. GPIO.output must be high. In case that you want to stop the motor, we never care its direction anymore. So you can use P1 start 0 or P1 start 100, but the GPIO output must be now low. For the sign magnitude, the command P1 start 100 is used to set up the speed to be full speed ahead, while GPIO.output is set to be low for moving forward and will be high for moving backward. To stop the motor, we never care its direction anymore, so GPIO.output can be set to be high or low, but P1.start must be 0. That means the speed will be 0. You may observe one thing. These two modes can be used to control on and off, and also the direction of the motor. But Only sign magnitude mode can be used to control the speed, like fast or slow. So sign magnitude is recommended to be used. One last thing, to run the Python code provided, name MDD10LA and MDD10SM stored in the folder codes, we simply click the fourth icon run this code as usual. But if we want to stop the running code, this cannot be done with last icon stop as usual, because all GPIO must be cleaned up and changed to the normal state before the model will stop. So press Ctrl and C to interrupt the running and clean up all GPIO. Otherwise, the model will keep running.